All right, here is our last lesson that we're going to do from chapter 1 in the book. And we're going to talk about writing with index sets. So make sure you've got your materials ready to take notes, and let's get started. So where this notation is going to come from is I want you to remember summation notation from last year, where you have this large sigma, you've got a bound, and then some terms. So in this case, the I starts at 1, goes to the upper bound to n of some term a sub I, that's a1 plus a2 plus a3, all the way out to that upper bound a sub n. Now, we have similar things for the operations in sets, but instead of adding sets together, we can either take their unions. So in this case, again, it's just going to be like another big symbol. We've got our bounds at the starting point and the upper point, and the set, because that's why it's uppercase, a sub I, so this would be the union of I1, I2, so on. Whoop, fix that a little bit. And all the way up to the upper bound n. And you can have it with the union, or you can have it with the intersection, similar notation here. So if we're going to use this notation, this would be the union of all the sets a sub I, starting at I equals 1 to I equals 3. And we're just given, in this case, an example. So here, for part A, we have A1 union A2 union A3, and we can expand those out with these 3 element sets that we have. So here we have all of our sets written out, and the union is all of the elements in any of them. So we have 0, and we write them in order. So the next one would be 1. So we have the 0 here, 1, and then 2, which we only write once even though it shows them in all of the sets. In order, next would be 5, and then 7. And this would be the union of the index sets from 1 to 3. Now if we're looking at the interval, if we're looking at the intersection, here we're looking at the intersection of the index sets 1 through 3. And now looking for the intersection, we're looking for what do they all have in common, and that would be 2 and 5. So in this case, the intersection of these index sets would be 2, 5. So here's a nice set where we just have them all listed out. As you can imagine, things get a little bit more complicated when you're looking at sets that are defined using these parameters like we have here with set builder notation. So here we have the definition a sub I is equal to x in the natural numbers, where x is a factor of I in the natural numbers. So first let's make sure that we all understand what this set looks like. So if I have the set, in this case a6, that means it's built of the natural numbers where x is a factor of I, which in this case I is 6, so in case factor of 6. And this is just going to require a little bit of memory from back in the lower school and elementary school. The factors of 6, 1, 2, 3, and 6. So that would be the set A sub 6. Now, when we're looking at our intersections and unions, if we're going through all the sets of, in this case, 1 to 6, this would be the union of all the first 6 sets in this index. And you could absolutely write them all out just like we did here, or you can use your skills to jump ahead a little bit. Either way works for me. If you want to write them out, please do that. Otherwise, I'm going to start by writing the union. I know from 1, the factors here are 1, and then we add 2 for the second. 3 has a factor of 3. 4 has a factor of 2, which we already have here, but also 4. 5 factors itself, and then 6 factors itself. So the union of all those index sets is just the numbers 1 through 6. Now, just like with series, you absolutely can have an upper bound that is infinity. So when we talked about infinite series a lot last year. In this case, sometimes what you'll see is this upper bound as infinity, like we see here in number C, or you'll see it as just a unadorned symbol where it just says that I is in some universal set. So if I was going to write out this problem with this kind of notation, I would say, oh, well, that's the same as the intersection of a sub I, and I, we know that that's in the natural numbers. So then we just say I in the natural numbers like that. So these two ways are just writing the same thing. Now here you can absolutely try writing all of these out, but there's going to be infinite and it's going to kind of be terrible. So what you can do then with a lot of these infinite ones is you want to use your logical thinking skills to be like, okay, what element was in every single one of these? And if you think about, this first example, we had 1. This one would have been 1, 2, 1, 3, 1, 2, 4, 1, 5, 1, 2, 3, 6. The number that is a factor of every n, because that's what this is asking in this specific index set. Well, the number that factors all natural numbers is 1. So some of these infinite interval intersections and unions are a little bit more of logic problems than they are pure sort of plug through, look at the sets problems. And you can absolutely use your prior experience there. Let me know if you have any questions about index sets in the comments, and if you are stuck on any of the homework problems, please vote and I will make a video explaining anything that you're confused by. I'll talk to you later.